Good morning, students. Dear students, as in the continuation with chapter 5, that is laws of motion, today we are going to discuss part 14 of the video lecture, and in this video lecture we will discuss about angle of friction, angle of repose, numerical based on angle of friction, and then we will try to discuss the another type of external friction, that is kinetic friction. Now I want to recap the previous video. In the previous video we had discussed about the sliding friction, and after that we had discussed about the limiting friction, the static friction. The maximum value of a static friction is called as the limiting friction, and the limiting friction is the maximum value of friction acting on the body. That limiting friction, we had discussed certain laws of the limiting friction, and we had calculated or derived the formula for coefficient of limiting friction. Now we will discuss about the today's video, that is angle of friction. So dear students, what is the angle of friction? It is nothing. It is the resultant of limiting friction and normal reaction. It is the angle of resultant of limiting friction and normal reaction, which it makes with the normal reaction. Dear students, first of all, understand what is the statement for the angle of friction described here. Is saying it is the angle of resultant of limiting friction. Means I am drawing a diagram to explain it. Suppose this is a block, and this block is placed over a rough surface. And here the block is just going to move over this rough surface due to the applied force. So the friction generated is called as Fx max, that is the value of limiting friction. If the weight of the body is, suppose if the weight of the mass of the body is m, then its weight is what? Its weight is mg. And due to this weight, by Newton's third law, there is a normal reaction R. It's clear? So this is the free body diagram of this mass m kept over the rough surface. Now, according to the statement of the angle of friction, it is the angle of resultant. Now we have to find the resultant. For this. This is the resultant limiting friction and normal reaction, which makes this is Now, according to parallel ground law of vector addition, clear? So this angle theta, what the normal reaction max with this is the resultant of Fs max and this is and what about the angle it max with the normal reaction? What about the angle it makes with the normal reaction? That angle is called as angle of friction. Now we are interested to find out the angle of friction. So if we name this AOBC, so in triangle AOC, look at here students, in triangle AOC, what you are observing in triangle AOC, we have to find the value of tan theta. So dear students, in this picture we have to find the value of tan theta, and tan theta is what? Tan theta is equal to perpendicular upon base. So the perpendicular is AC, and this is hypotenuse and this is base, so OA is the base. Now what is the value of AC? So value of AC is equal to Fs max. Value of AC is equal to Fs max and OA. This OA, this is the parallel shifting of vector, it does not change, and OA is the normal reaction. So tan theta is equal to Fs max upon R, and as we had studied that Fs max upon R, it is called as μs, that is coefficient of static friction, and from here we can write that tan theta is equal to μs. It implies that theta is equal to tan inverse μs. This is the angle of friction. Theta is equal to tan inverse μs. So we can say that coefficient of static friction, is the tangent of angle of friction. Here theta, look at it. Here theta is the angle of friction. Theta is the angle of friction. So tan theta is the tangent of angle of friction, and this is equal to the value μs, which is the coefficient of static friction. So tan theta is equal to μs, that is coefficient of static friction, and this angle of friction, since theta depends on μs, so and μs, as you know that μs depends upon the two surfaces in contact. So we can say that angle of friction depends on the two surfaces in contact. So we can say that angle of friction depends upon the two surfaces in contact. Clear, students? This is all about the angle of friction. Now I think we have to solve one numerical based on angle of friction. So look at that numerical. Yes, students. Now look at the numerical which is in front of you, and in this numerical a force of 49 Newton, a force of 49 Newton is sufficient to pull a block of wood of weighing 10 kg. It is the mass of the block, it is given on the rough horizontal surface. There is a rough horizontal surface, so I am drawing the diagram here. Suppose here it is a rough horizontal surface and a block of mass 10 kg is placed over this rough horizontal surface, and a force F is applied here, and that force is equal to 49. This force is equal to 49 Newton. So calculate the coefficient of friction and angle of friction. You have to calculate the coefficient of friction and angle of friction. So dear students, here it is the sufficient force, that is maximum force, which is applied on the wooden block to make the block move on the rough surface. So for this force there is an opposing force, that is Fs max. That is the limiting friction, that is the limiting friction, because it is the maximum or sufficient force which is required to pull the block on this rough surface. And as its weight is 10 kg, so it is equal to mg. While solving, we will put the values. Now, due to mg, there is a normal reaction R. Clear, students? Now, here we have to find μs and then angle of friction. Clear? So first of all, this is the angle of friction, that is theta, which the resultant of Fx max and R is making with the normal reaction, as we had studied before. So we have to, first of all, we have to find R is equal to mg. So R is equal to mg, and here it is given 10 into 9.8, 10 into 9.8. Clear, students? Now we have to find out the coefficient of friction μs. So you know that first of all we have to find the Fs max. We have to find the value of Fs max, and Fs max is equal to μs into normal reaction. Clear? So from here we can calculate the value of μs is equal to Fs max, that is upon normal reaction. And as we can see that this force is sufficient to pull the block on the rough horizontal surface. So this Fs max is equal to this force. So we can write it as F upon R. So F is equal to 49 Newton upon normal reaction 10 into 9.8 Newton. 10 into 9.8 Newton. Clear, students? And I think it will be 0.8. I think value of μs will be 0.05. It will be 0.1 upon 2. Look at here, 98, so it will be 98. It will be 1 upon 2. So it is equal to 0.5. So μs is equal to μs, you had calculated μs is equal to 0.5. Now we have to find out the angle of friction, and as you know that angle of friction, that is tan theta, is equal to mu. Angle of friction angle of friction, angle of friction, and this angle of friction we can say that tan theta is equal to mu, and we can write it as theta is equal to tan inverse mu, or you can write it as theta is equal to tan inverse 0.5. So this is the required answer for the angle of friction. This is the required answer for the angle of friction, and here we get this value of theta as tan inverse 0.5. So this is the numerical based on angle of friction. Now we will start our discussion for angle of repose. So dear students, look for angle of. So dear students, now we will study about angle of repose and how you can define angle of repose. First of all, I want to define you about the angle of repose, and then we will come for the mathematical expression for the angle of repose. So it is the minimum angle with which a plane is inclined over the horizontal surface such that with that angle the body just starts sliding over the surface. That angle is called as angle of repose. That angle is called as angle of repose, and it is denoted by alpha. This angle of repose is denoted by alpha. So dear students, let us understand this case with the pictorial diagram. Suppose I am saying that this is an inclined plane, and over this inclined plane a block of mass m is placed. Over this inclined plane a block of mass m is placed, and with this inclination the block slides down over the inclined plane. So this is the angle of repose. Now how you find this angle of repose? Clearly here this is the normal reaction and in this direction, and the weight of the block mg acts on this. Now break this weight mg into two components. Clear, students? So if this angle is alpha, then if this is the plane, and if we had lifted this plane, then this normal reaction is also going to be shifted by an angle of alpha. This normal reaction, suppose this is in this way, and if we are going to shift in this way, then it is shifted by an angle of alpha. So this becomes mg cos alpha, and this become mg resolution. We had resolved the weight. Mg weight is acting downward. This is mg sine. This is mg sine alpha, and this is mg cos alpha. And since this inclined plane ABC, suppose we are supposing it inclined plane ABC, then it is a rough surface. So there is a frictional force Fs max. There is a frictional force, that is the limiting value of friction, that is Fs max. So this is the free body diagram. This is the free body diagram we have drawn for the block of mass m. When it is inclined at an angle alpha and it is going to be slide over the rough surface, then this is the free body diagram. Now we will try to balance all the forces. So first of all, this is the weight mg, and this is mg cos alpha. First of all, normal reaction, since there is no any motion in horizontal and vertical direction, so we balance the forces. M minus mg cos alpha is equal to 0. N minus mg cos alpha, since there is no any motion in the vertical direction, so it can be written as n is equal to mg cos alpha. This is equation number 1. Now resolving the forces in this direction, since resolving these forces in this direction also, Fs max minus mg sin alpha is equal to 0, and we can write it as Fs max is equal to mg sin Fx max is equal to mg sin alpha. This is equation number 2. Now dividing equation 2 by equation 1. Dividing equation 2 by equation 1. I am writing students here. Dividing equation 2 by equation 1. Dividing equation 2 by equation 1, and on dividing equation 2 by equation 1, we will get Fs max upon normal reaction R or N, whatever you say, normal reaction N is equal to mg sin alpha upon mg cos alpha, and it will cancel out, and here we will get Fs max upon normal reaction is equal to tan alpha, and Fs max upon normal reaction or Fs max upon R, we had studied it is equal to Fs max upon tan alpha, and it is equal to, in place of coefficient of discussing with the coefficient of static friction, we have discussed that Fs max upon R or Fs max upon N is equal to mu s, that is equal to tan alpha. Clear, students? Or alpha is equal to tan inverse mu s. Alpha is equal to tan inverse mu s. So here we can say that angle of friction and angle of repose are angle of friction and angle of repose are the same. So angle of friction is equal to angle of friction is equal to angle of repose. As we had seen that in the discussion with angle of friction, we had seen that Bus is equal to tan theta, and here we had seen that Bus is equal to tan alpha. So in both cases, the coefficient of static friction is the tangent of angle. So we can say that angle of friction is equal to angle of repose. So we can say that theta is equal to alpha. It means that tan theta is equal to tan alpha, and it means that theta is equal to angle of friction is equal to angle of repose. Now dear students, this is about the angle of repose and angle of friction. Now we will discuss about the coefficient of kinetic friction, another type of friction, that is the kinetic friction. Another type of external friction. We will discuss the another type of external friction, that is kinetic friction. So